In this video, we will learn about frames and machines, topic 6.6 from chapter 6. Frames and machines. Today's objective is to draw the free body diagram of a frame or machine and its members and determine the forces acting at the joints or supports of a frame or machine. Now, there is a difference between trusses and frames and machines. So trusses have all the members which are two force members. Means if there is a member of truss, then it's subjected to load only at its endpoints. Okay, so it's a two force member. It's a rigid structure and does not transmit any motion. For example, the frame of a roof, it does not transmit any motion. On the other hand, the frames have at least one force which is one member which is multi-force member. For example, this member is called multi-force member because it has more than two forces. Frame is also a rigid structure and it does not transmit motion as well. So the key difference between truss and frames is that there is at least one multi-force member. Machines, on the other hand, are different from the above two category in the sense that the machines have at least one multi-force member like this, like frames, but the main intention of the machines is to transmit motion and power. So machines, they transmit motion and power, and frames, they do not do that. So frames are mostly used for supporting structures, and the machines are used for transmitting motion. Frames and machines are different as compared to trusses since they have at least one multi-force member. So there is one thing which is common in frames and machines is that there is at least one multi-force member. Forces common to any two contacting members act with equal magnitude but opposite sense on the other member. Applications. Frames are commonly used to support various external loads, as you can see here, like the structure of frame. How is a frame different than a truss? So frame, they have at least one multi-force member. Machines like those above are used in variety of applications. How are they different from trusses and frames? So machines, they transmit motion and power. How can we determine the loads at the joints and supports? So for if to design this machine, we would like to know that what are the loads at these joints, okay, as well as the supports. And these forces and moments are required when designing the machine's member. So on the left side here, what we see is a frame. On the right side is a machine. Frames and machines are two common types of structures that have at least one multi-force member. Recall that the trusses have nothing but two force members. Frames are generally stationary and supports external load. Machines contain moving parts and designed to alter the effect of forces. So this is an example of the frame or machine where you can see that this is like multi-force member, and here we have drawn, we can see two different free body diagrams, one for member BC and one for member AB. AB is a two force member, but BC is multi-force member. BC has more than two forces. As well as another thing to notice here is that at B, both member AB and BC are joined. So FAB has the same magnitude at B on both the members, but the opposite sense. So this is going up and this is going down. In the steps, first draw the free body diagram, identify any two force members, and then for a joint more than two force members or external forces, it's advisable to draw a free body diagram of the pin. And then develop the strategy, apply the equations of equilibrium to solve for the unknowns. And now there are a few examples that we will do in the next video, but before that, we will look at this example here. Like for in this pulley system, it is designed to reduce the human efforts to lift the load. How can we calculate the amount of force required to lift 100-pound load in each one of this system? This is very practical application of pulleys where we can give much more lower force to lift heavy weight. So let's start with simple example that we have only single pulley and there is a cable that goes around that pulley, and the weight attached at the end of pulley is 100 pound. What is the tension in each one of this cable when the system is in equilibrium? That means the load is not moving, so it's just like staying there. So for that, you can define this as y-axis going up as positive, and we can write down the equation sum of forces in y direction equal to 0. Why 0? Because the system is in equilibrium and going up is positive. So we have T plus T going up, but we have W which is going down, it's 0. Therefore, 2T is equal to W. Therefore, T is equal to W divided by 2, which is 50 pound. So if we have two cables supporting the weight through the pulley system, then each of this cable carries 50 pound when the system is in equilibrium. Now let's apply this concept to all these examples. So for the first one, we have 100 pound weight which is being supported by, now there is only one cable which goes through here. So the cable goes all the way from this big pulley to this middle size pulley to this third pulley to fourth pulley and back to the frame supporting hook. So this W is being carried by 1, 2, 3, and 4T. So T. So in this case, this W 100 pound is divided equally among these four cables. So load in each cable is 1 by 4th of 100. So it's 25 pounds. So 4T is equal to 100. Therefore, T is equal to 25 pound. So this cable has load 25 pound. That means it's the same cable that goes here. So P is also 25 pound. So we need to give 1 by 4th of the force that we are lifting. So to lift 100 with pulley system, we just need to give 25. This is for case A. For case B, this 100 is divided by 3. So T, T, and T. So this P is equal to T in this case. So it's for case B, it's 3T is equal to 100. Therefore, T is equal to 33.33 pound. Therefore, P is equal to T is equal to 33.33 pound. Okay, so that we have solved for the second case. Now third, C. This 100 is divided by 3. So it's being supported by 3 cables, T, T, and T. So this cable has 33.33 pound. This cable supports that much tension. Now that cable is further divided into 3. See, that cable is connected at the hook at the center of this pulley, which then supports, which is then being supported by 3 ends of the cable. So each one of this is 1 by 3rd of this. So this is 11.11 pound. Each one of these. So P is 11.11 pound. Okay. Thank you.